Hello, everyone. I'm super happy to be here today. I'm also super honored to be able to introduce Michael Abrash. Michael Abraj is the chief scientist of Reality Labs at Meta. Reality Labs, as you might know, is a research laboratory that brings together a world-class team of R&D scientists, developers, engineers to build the future connection within VR and AR. But only that, previously he was a graphic lead of Windows NT, teamed up with John Carmack on Quake, worked on 2 versions of Microsoft Xbox, and helped develop VR at Valve. Without further ado, Michael, the floor is yours.
Thank you, Leen. Imagine that it's 50 years ago, and you're at the Xerox Palo Alto Research Center, Xerox PARC. And let's imagine that you're part of the discussion about building the Alto, the first true personal computer. Would you have envisioned the world we live in today? A world where the modern-day descendants of the Alto, the desktop, laptop, and smartphone, have become an indispensable part of our lives? Unless your name is Alan Kay, probably not. But would you have felt that there was tremendous potential there, a fundamental shift in the relationship between humans and computers? Well, that would have depended on how far your imagination could stretch. But if it was capable of stretching far enough, you would have been positioned to ride a once-in-a-lifetime technology wave that's still going strong a half-century later, the first great wave of human-oriented computing. Right now, that wave feels like it will run forever, but there's a second wave that's just starting to rise, and it's going to be even bigger and run for longer. Because while the first wave was a compromise that worked around technology limitations, the second wave has the potential to create a far richer relationship between humans and computers, one that will, for the first time, be built around people's capabilities and needs, rather than requiring us to conform to computers' needs. It'll take decades to fully realize that potential, but the ultimate destination for the metaverse is nothing less than enabling us to explore pretty much the entire range of possible human experience. And it's hard to imagine anything more fundamentally transformative than that. The challenge, of course, is that the technology that will make that happen doesn't yet exist. But at Meta's Reality Labs research, our mission is to create the future augmented and virtual reality technology that will underpin and enable the metaverse, creating the foundation that millions and ultimately billions of people will be creative on over the years. I've been leading this effort for more than 8 years, and I have to say it's pretty satisfying after all this time to see the world getting excited about the metaverse. However, we're just at the start of a long journey. Realizing the full potential of the metaverse will require pushing the state of the art forward in a dozen fields over many years. Before I talk about that, though, I'd like to discuss why I believe that the metaverse is the right vision for the next 50 years. And a good place to start is by looking at the last 50 years. Over the half-century since Xerox PARC created the Alto, the personal computer and its evolution into mobile computing have together led to every one of us being just seconds away from the virtual world almost every waking minute. This is the first great wave of human-oriented computing, and it has completely changed the way that we work, play, and communicate. But even so, today's virtual world is only an intermediate step on the way to the full realization of the human potential of personal computing. That's because today's virtual world has one great limitation. We interact with it almost exclusively through two-dimensional windows that bring the virtual world into the real world in a limited way that uses only a small subset of our inherent information processing capabilities. For example, as every one of you knows, we can see people on our screens, but we don't feel like we're really present with them. The way we experience the digital world still feels nothing like how we experience the physical world. See, through our sense capable of processing huge amounts of data. However, much of that processing happens below the conscious level, and in particular, it is our unconscious that gives us our sense of reality. Similarly, when we take action in the world, we primarily use our 25 degree of freedom manipulators, our hands, which are capable of providing vastly richer actions than just touching a screen or using a mouse and keyboard. For all the remarkable things they've enabled, our phones and computers don't come close to tapping into our brains and perceptual systems' full potential. And so they force us to adapt to their limitations. In contrast, by being able to drive our senses with immersive audiovisual input that's starting to approach real-world experiences, VR and AR let us access information in the ways we're built to work with it, mixing real and virtual freely. And by letting us use our hands to directly manipulate virtual objects, complete with a realistic sense of touch, they will also give us dexterous agency in the virtual world. Finally, by seeing the world from our personal perspective, they will be able to, for the first time, understand our goals and our needs and help us achieve them in intuitive ways, enhancing our perception, our memory, and our cognition. That will let us learn, connect, collaborate, and problem solve more effectively. This will be the second great wave of human-oriented computing, and it will once again fundamentally change our relationship with the digital world, and this time, it will let us do more of what makes us human. So that's why I believe AR/VR will shape the next 50 years every bit as much as personal computing shaped the last 50. It's the logical endpoint of human-oriented computing, and we'll see examples of progress in that direction shortly. That AR/VR future holds tremendous potential, but it could evolve in many different ways. This is an exciting time in that respect. Because we're still right at the beginning, we have a once-in-a-generation chance to think about the societal impact of the next computing platform while it's still being built. We take that responsibility very seriously, but it's not ours alone, nor should it be. It will require broad input, engagement, and discussion from across society. Today, I hope to help that process along by sharing what RL Research is working on so that we can build a common understanding of what's likely to be coming over the next decade. So, with that in mind, what will the AR/VR future look like? What will that next generation platform do? I'm going to distinguish here between AR and VR because due to limitations, they are currently very different technologies that will play different roles in our lives for many years to come. Let's look at VR first. I think of VR as the successor to the personal computer, and making that happen will require a great deal of new technology. While VR 1.0 is changing the landscape today, and Cambria is on the way, RL Research is working toward the next generation of VR headsets that will land 5 to 10 years from now. That will be a broad platform with a wide variety of uses, many of which haven't even been conceived yet. But one application that I believe can have a hugely positive impact is remote work. Horizon Workrooms is an important first step in that direction. Thanks to technologies like spatial audio and hand tracking, it provides a glimpse of the future of virtual work. However, as interesting and useful as Workrooms is, the future of work in VR is so much more. Imagine a VR headset that's a sleek, stylish, lightweight visor with virtual audio and visual experiences that are nearly indistinguishable from reality. This headset would let you use your hands to manipulate virtual objects and would let you interact with your real and virtual surroundings simultaneously by passing through whatever parts of the real world you are interested in, like your real-world coffee cup, a technology known as mixed reality. And you could have virtual workspaces with configurable screens for productive solo work, and virtual social interactions that felt like genuinely being with your coworkers in a physical workspace. This would be a true game changer. For one thing, where you are in the world would no longer dictate the opportunities available to you. Now, you might think that's already true with the internet, but VR remote work will be a step change beyond that. For example, imagine that you scan a conference room to create a perfect digital replica of it. Then you have a meeting with half the people in that physical room and half the people remote, with everyone wearing a VR headset. Everyone, whether physically present or remote, sees the same room, and they also see everyone else's avatars in the room, along with virtual tools such as screens and whiteboards. Everyone is on an equal footing, and everyone gets to use virtual tools that will ultimately be much more powerful than real tools. As one example, consider a virtual whiteboard. It's infinitely expandable, can contain videos and pictures, is archivable and searchable, and everyone can have their own view of it. It's as much better than a real whiteboard as Office is better than a typewriter and calculator. That's the future of work. Now, that headset doesn't yet exist, although Cambria will be an important step in that direction. But for the last 8 years, RL Research has been pushing the envelope on all of the technologies that will be needed to build it. I want to show you our progress in 3 key areas today: avatars, replicating the real world, and haptics. To collaborate in a virtual workspace, or just to visit with family and friends, we'd want lifelike avatars that allow us to interact in virtual reality in real time. We've shown codec avatars before, but this is one of the first times we've shown the huge leap forward in realism of codec avatars 2.0. As you watch, bear in mind that the head facing you is an entirely virtual reconstruction. The real-world version of Jason is wearing a headset at the lower right.
I can raise and lower my eyebrows, I can squint, widen my eyes, I can look left, right, around, I can scrunch my nose, I can smile, I can be angry, surprised, I can be scared, I can wink at you. So we can do all these things, but perhaps the most important aspect of facial behavior for a social interaction is the ability to make and maintain eye contact, even as I move my head around naturally or move with respect to you as we're interacting.
It doesn't take a lot of imagination to see that doing this in VR could be far more satisfying and personal than seeing someone's image on a flat screen. But realistic avatars are only part of the picture, because you'll also need realistic virtual be with people in. Here's an example of our early room reconstruction technology that we showed in 2019 at Oculus Connect 6. I want to emphasize that what you're seeing is the real thing, with no smoke and mirrors. This is a fly-through of 3D replicas of real spaces generated by state-of-the-art reconstruction technology. Here's a more recent example. What you're seeing isn't an actual apartment. It's a reconstructed replica of an actual apartment, which becomes pretty obvious right about now. Here you can see Ming Fei moving around various objects on the right. You can see a high-fidelity, real-time render of the space and the moving objects on the left. The fact that this is all happening in real time makes it very different from the sorts of CGI scenes you see in movies, opening the door to a multitude of shared mixed reality experiences, such as the collaborative workspace I described earlier. Now, what we really want is the whole package, a full-body avatar in a virtual environment. We're still early in that process, but here's a peek into that future.
Hi there. My name is Yasser, and I direct the Facebook Reality Research Lab in Pittsburgh. Well, that's not completely true. What you're seeing is actually a rendering of my pre-recorded codec avatar. Over the past couple of years, we've made quite a bit of progress with codec avatars. My avatar can now look left, look right, look up, look down, make facial expressions.
Here you can see Leen is in VR on the right. You can see her view of Yasser's avatar and the reconstructed real-world space that it's in on the left as she moves around the avatar. What you see on the left is not a video. It's an entirely virtual reconstruction. This gives you a sense of a future in which you'll be able to interact with another person's realistic avatar in real time, in either a reconstruction of a real space or a created space in the metaverse. I'd like to quickly look at one other area that we're advancing the state-of-the-art in, haptic feedback. We've talked a lot about what we'll be able to see, but we also want to actually do things in the metaverse. And while being able to see your hands in VR and manipulate virtual objects, which you can do today with Hands in Quest, is a big step forward, we can't be as dexterous in the virtual world as in the real world without haptic feedback. One of our longest-term, most speculative research projects is aimed at developing soft, lightweight gloves that can reproduce a range of sensations, including texture and pressure, to make the metaverse tangible. It is tremendously challenging to enable hands to be truly dexterous in the metaverse. We've been working on it for more than 7 years now, and we're only partway there. But we're making real progress, and there's a good chance that sooner or later you'll be pulling on a pair of gloves and interacting with the virtual world as deftly and intuitively as with the real world. Now let's turn to augmented reality, which lets us experience virtual objects placed in the real world. Consumer AR glasses are technically much harder than VR headsets and are still at a very early stage. But as the technology evolves, AR glasses have the potential to do everything smartphones do, and much more. Imagine having a pair of stylish AR glasses that could enable you to teleport to a park for a chess match, and that would allow you to access your virtual workspace no matter where you were. They would help you hear better in noisy environments, and see better in low light, and could help vision and hearing impaired people function better. You could have a truly personalized assistant that could feed you key statistics in a business meeting, guide you to destinations, and translate signs on the fly. And you could leave a 3D message for your daughter on the fridge or see what's on tap just by looking towards the bar. If those glasses existed today, I believe we'd all be wearing them right now. And everything I just described is physically possible, and I have no doubt that in the not too distant future, we will be wearing glasses that deliver on the full promise of AR. However, as I mentioned at the beginning, the technologies that would allow most of that to happen don't yet exist. But they will. We've been working for 8 years to develop those technologies, including audio that lets you hear and be heard no matter how noisy the environment, display technology that enables full AR while fitting in consumer glasses, and sensors that need only a few milliwatts to handle everything from bright sun to nighttime, enabling them to run all day. And the codec avatars we saw earlier will enable conversations on the go that will make you feel like you're truly present with other people.
Well, what can your face do? Can you show us?
Well, I've always hoped you would ask me that question. So I have some pretty good, I think, mouth movement.
Given our limited time together, I'd like to focus more deeply on just one other area that we're advancing the state of the art in, one that will reshape the way we interact with the digital world, the AR user interface. In the 1960s, a researcher named Doug Engelbart became obsessed with the problem of human-computer interaction, invented the mouse and the graphical user interface, the GUI, and defined the way we would interact with the digital world for the next half-century. Unfortunately, AR glasses have needs that GUIs simply can't handle. They need to be able to work in much the same way that your own mind works, seamlessly sharing information and taking action when you want it, and not getting in your way otherwise. And they have to be able to do that in every situation you encounter in the course of a day. So, like Engelbart, we need to invent an entirely new type of interface. And this time, it needs to be an interface that places us, rather than our devices, at the center of the computing experience. One key part of that will be the ability to communicate with our devices intuitively and frictionlessly, and that will require personalized, contextualized AI, combined with a type of input that simply doesn't exist today. We believe the key AR input technology of the future will be electromyography, or EMG. EMG, which you can see in action here, allows you to control your AR glasses with simple, easy-to-learn gestures, using sensors worn on your wrist that pick up neuromotor signals with remarkable precision and translate them into digital commands to control your devices. This video shows some of the ways we believe that wrist-based EMG will be the core input tool for AR glasses. At first, EMG will take the form of basic gestures like click, scroll, and select. But as the technology evolves, EMG has the potential to unlock full-speed typing, subtle personalized controls, and new forms of expression. This is genuinely unprecedented technology and could be especially transformative for messaging on the go. For instance, this experimental swipe-based UI shows how EMG could, one day, allow you to easily send a message in AR with your hand resting comfortably at your side, or even in your pocket, without having to look down at a screen. But that's just the beginning. It's also highly likely that ultimately you'll be able to type at high speed with EMG on a table or on your lap, maybe even at higher speed than is possible with a keyboard today. So that's pretty cool, but it's just the input part of the interaction equation. The other part is AI that understands your context and can present you with a simple set of choices based on that context. This system will constantly infer what information you might need or what things you might want to do as you go about your life based on the data you choose to share about yourself and your environment. Whenever it's confident that it can assist you, it will present you with the right set of choices, which you can then quickly and easily choose among using EMG. The ultimate goal is to build an interface that adapts to you and meets your needs as automatically as possible, and is able to ask a simple question to disambiguate when it isn't sure. When that technology is mature, it will make AR glasses highly intuitive and very useful, almost an extension of yourself. Here's an early research project toward that personalized interface. You can see how, as Ming-Fei is walking around the apartment, her research prototype glasses are constantly figuring out what objects she's interested in, based on analysis of her surroundings and the direction of her eye gaze. That contextual information, in turn, enables the system to offer proactive assistance to Ming-Fei in a variety of ways. Here, the system knows her attention is on the TV, so when she clicks while looking at it, the system turns it on. Note that the clicker is not turning on the TV. It's communicating to the system that it should go ahead and perform the action it has inferred she wants. This is similar to the role EMG will play in the future. A lot of these AR and VR technologies are still at a very early stage, but this should give you some sense of their enormous potential to shape the way we live for decades to come. And make no mistake, that future is coming in the form of the metaverse that will be built on the AR/VR foundation we're developing. And as I mentioned earlier, the real question is the form it will take and the ways in which it will change the world. That's why we're actively seeking open discussion about the ethical standards and principles that should guide these technologies as we bring them to market. And sparking that discussion is one reason I'm sharing this with you today. The other reason is that I just want to share how amazingly cool the metaverse is going to be. This is a once-in-a-lifetime technology wave, and I encourage you to catch it now, right at the beginning. We can't do this alone, and we don't want to. It's going to take a global effort to realize the world-changing potential of AR/VR. So I hope that you'll not only ride that wave, but help make it happen. After all, how often do you get to transform the world? Thank you.
Hi, Michael. First of all, great to see you again.
Great to see you.
So what I didn't say in the introduction is the reason that, one of the reasons why I'm here is that Michael and we met 2 years ago, pre-COVID, because he was actually visiting Brussels, but also a couple of other European countries. We met then, and I was a speaker as well. I was interviewing him on stage. So a couple of my questions will reflect the conversation I had with him back then. So also, I'm very, very excited not only to be here, but I also had the opportunity to have a look at these amazing insights that were shared with me 2 weeks ago. So I prepped some questions. I hope you agree that these are good questions for the talk. So first of all, as for the avatars, you have introduced the CogX Avatars 2.0 for the first time, which look amazingly real. One could imagine lots of cameras and top-notch tech are pulled in to recreate these avatars. So the question is, what is key to track and to capture? But how do you see this process evolve to make it scalable for everyone to use?
That's a great question, and it is absolutely true that right now there are lots of cameras involved. Now, what I should say is that there are not lots of cameras involved in actually tracking the person in real time. We can do that right now off of cameras on a headset. The real challenge is, how do we build your personalized avatar? Today, that requires sitting in a scanning environment for quite a long time, and then it involves a great deal of processing after that. And what we need to do is get to the point where we can really just take, a few pictures or a few videos, create your avatar, and off you go. So there are many other challenges. There's still plenty of research to do here, but as you can see, things look pretty good. It's really getting it to be personalized and consumer friendly that is quite a challenge, and that's going to take a while.
again, in the context of these avatars, in the past and a couple of talks that you had on the subject, you talked about biological motion. I think it's quite an interesting topic. Can you clarify this concept and why it's critical to achieve true co-presence in VR?
Yeah, what's interesting is that having things look right is useful and necessary, but having things move properly turns out to be even more important. That people aren't always going to want to look exactly the way they look at the moment. They will want to accessorize themselves just like they do right now, different clothing, different hair, different jewelry and so forth. And so in order to make a person, in other words, what makes you, you need to move like you. So I have specific hand gestures. I have a certain way of smiling. We need to map that motion, which is called biological motion, into whatever avatar you choose to be using. So there's both the static part that I would say, which is looking right, and there's the dynamic part, which is moving properly, and they're both necessary.
Thank you for clarifying. Also in your talk, you confirmed the objective of not building the next computing platform alone. So you mentioned broad input, engagement, discussion from across society will be requested. How are you going to do this? And can you give us some examples?
So the biggest way that I would say that we're doing that is we're being very open and we're sharing. So for example, I'm talking today about what we're doing, and I've been doing that actually now for 8 years. If you go back through all the Oculus Connects and the F8s, you'll see that I've been doing that. And we also have been publishing a lot. We publish hundreds of papers, so we're talking about what we're doing. And we have lots of academic collaborations, more than 100 academic collaborations. And we are encouraging this discussion as openly as we can. And I'm looking forward to that discussion. I hope that as a result of this, there's more of that happening. So we're sharing our knowledge, we're sharing what we're doing, and we're encouraging conversation about it.
In your talk today, you make a clear distinction between VR and AR, and you clearly postpone the timeline of expectations of AR versus VR. If I remember our first talk in 2019, well, back then AR was much more the short-term focus. So the question is, what has changed? Even more so that over the recent years, the market potential of AR remains on average 3 times as big.
Well, my take on it is that both AR and VR are critical parts of the future. And at the time that you and I met, I was really talking about AR because that was the information that I was sharing in the conversation that I was trying to spark. But I think people undervalue exactly how important VR is going to be. So I think of VR as the successor to the personal computer, the productivity environment, because for a very long time, it will be a richer environment with more capability because it doesn't have to be mobile. It doesn't have to be so socially acceptable. It can use more power and so forth. Where AR, I think as everybody sees, is the successor to the smartphone. It's the thing that is always with you, that keeps you connected. But don't undervalue that productivity side, because right now I think a lot of people think of it as if, well, smartphones are the present and PCs are kind of the old guard. But there's still well over 1 billion PCs out there, and they do a lot of productive work. And so think of it as productivity and always available connectivity. And both of those will happen. One will be VR, one will be AR. So I have no particular emphasis in either direction. They're both need to happen. They both will happen.
Thank you. Only just recently, it was announced that the Facebook AI research team, or FAIR, has joined the Reality Labs research division, underlying the importance of artificial intelligence for Meta and the future metaverse. Can you elaborate on this, and why is it a good thing that FAIR moved to Reality Labs research?
Well, I mean, at the most basic level, we've now joined the 2 true fundamental research groups in Meta into one, and that can only be a good thing. But so AI is integral to almost everything. So for example, the hand tracking that I showed briefly, Hands in Quest, there's lots of AI in that, lots of machine learned type stuff. And graphics, there's lots of that. And it's kind of, if you look at everything, it's there. It's like programming languages at this point almost. It's just part of all these technologies we're evolving. But the specific reason why I am so excited about this change is that interface that I talked about. Because what we're going to develop is we're going to develop this contextualized, personalized interface that really genuinely makes you more capable, right? It works the way that you would want your memory to. It helps you do things well. It just makes life easier. And that is an AI problem in the end, but it also requires all these other pieces that we've been putting together around it. So what I look forward to is I look forward to using that interface, and bringing our teams closer together is going to make that happen sooner.
The next question is related to EMG. So how does electromyography fit into the vision of the future of human-computer interaction that you just laid out?
So one of the things about having that intuitive, like always there, always helping you interface is that obviously AI can't read your mind. It won't always know what you need, but what it can do is it can scope your choices down to one or two choices, or it can just ask you a quick question, and the two, you can basically co-learn your preferences. But to do that, you need very low friction, very easy to use input. And EMG is exactly that. It's something you put on your wrist, just like you put a watch on, and it's just there, and you can use it anytime you want. In the long run, EMG is also exciting because it has the potential for high bandwidth. And so it can be really this very, very effective interface that's the mouse, the keyboard, and more of AR. So I am also very excited about that because it's a key piece there of enabling us to interact with the digital world almost frictionlessly.
Yeah, you mentioned it clearly accelerates Meta's vision for AR, but does EMG have a place in VR as well?
I love that question too. So to me, it is obvious. You're wearing AR glasses, you're moving around the world, you really want the glasses to have this AI capability to bring things to your attention when you want them, to help you out with things, but not to get in your way. And that seems to me pretty obvious. You're going to want to navigate to places, you're going to want facts about doing things, you're going to want notifications and so forth. Just a simple example, if you're talking with someone, you don't necessarily want to see a message, right? Because that would be distracting. But then again, the message may be important enough. Having the AI able to judge when you should be interrupted and by what level of things, that would be super helpful. Okay, so now the way people think about VR right now is, well, you use game controllers, and that's great for game type stuff. But in the long run, when you're in the metaverse in VR, when you're in a world with other people doing basically everything, having meetings, going places, and so forth, it's the same as being in the real world. You're going to want to know how to get places. You're going to want facts about things. You're going to want notifications. So what I anticipate is that this interface will evolve in AR where it's absolutely necessary, but it will also become the interface for VR because it's the way you just want to interact with the complex world, real or virtual.
And this would be immediately the last question. So in February 2020, I noticed that Magic Leap introduced its whiteboard app, similar to the whiteboard feature basically that you introduced in the beta version of Horizon Workrooms. Why today Meta is rolling this out in VR and not in AR as Magic Leap does?
Well, I don't think there's any specific difference between AR and VR for having tools like this. However, there are millions of VR users right now. And again, VR is just a richer environment. So the logical place to do it is to roll it out where there are people who would immediately be using it. But in the long run, I mean, why would the tools work in one place or not another? Now, I will say that AR glasses, at least today, they're see-through glasses that add virtual pixels to that. And what that means is you can't draw black. You can only add additional light to what you see. And so if you think about how solid a whiteboard is going to look, how good the contrast is going to be, how sharp the image will be better in VR. So it is the place where you have these better, richer experiences, at least now. As technology evolves, we'll see how that changes. Sure, 20 or 30 years out, you may have just this one thing and it's AR and it's VR and it works for everything, but there's a long way to go. And keep in mind that it has been 49 years since the Alto was built, and we're a billion times faster and we're still evolving on that path. So we're going to be evolving on this AR VR path for a very, very long time. Anybody who chooses to work on it now can spend the rest of their career working on it. Challenges will be just as interesting, just as great down the road. They'll just be more advanced.
Well, with this, I'd like to conclude this session. I think all the insights that you've shared are super exciting, and personally, I don't hope they will last too long, but happen in the short term that we see these technologies and those innovations. So thank you for sharing your insights, and thank you for joining us here in London.
Well, thank you, Leen. Thanks for the opportunity.
Thank you.